if you go back to where they were posted originally, there's a little solution there. Yeah, absolutely. All right, we're ready to play Vegas now. We're ready to play Vegas, and part of your quizzes for next week will be playing Vegas even further. So here is our distribution. I think it's gorgeous. I love it. Proud of myself. What I'd like to do now is figure out, on average, how much we earn when we play. How much do we earn when we play this game? So in other words, knowing this, and what I can do is I can also take this out, because that was just conversational. How much do I earn on average? That's what we did yesterday, right? Once you have a distribution, you know what's going to happen over time. So crunch it. Crunch, use your TIs. There's a weighted average, yes? If you want to do it by hand, of course you can. That times that, plus that, times that, plus that, times that, plus that, times that. No, thank you. That's totally fine, too. It's totally fine. No, thank you. I think I'll pass on this. Yeah, this is just, it's a weighted average. Like, how many of you guys did the snowfall quiz for today? Anybody did the snowfall quiz? When did this? How does one person? Okay, never mind. Not an example. Thank you, Nick. For Nick, it's just like that. For the rest of you, it's just like the snowfall quiz you didn't do. No, but it's just like every other weighted average we've been doing. Marty, ask me that question.
You would do that in a list?
Yeah, list 1 and list 2. Because you have data, your data still is the payouts from the game. And your weights are the probabilities. And this is one of those cases, Ariel, thank you for that question earlier, where we're answering your question again. Your question again is so good, is which standard deviation do we use? We're going to ignore it, actually. The standard deviation is so skewed in this one, we don't have to worry about it, but you're going to see which one you get from this one. So let's do it.
Oh, it doesn't like negative.
Hold that thought, Oh, make sure you're using the negative button, sorry.
Oh, okay.
You got to use the button down here for negative.
Got it.
Yeah, let me swing that around. You just need to put. If anybody's around next year, I got the work study position approved for camera operator / video editor. So, anybody's around next year, we got some work study hours for you. I can promise you probably 20 hours a week. And you figure coming to class 4 hours a day. Sorry, next year. Next year. As in, that's why I said if anybody's still here, I'll bet you a bunch of you guys are graduating. So here we go. It's going to change you into decimals. 125 divided by 216. There they are. I like the decimals personally because now we get an idea. Because fractions are hard. Like 125 out of 216, that's more than half. But how much more than half? Like you lose that idea of how big it is. So roughly 58% of the time, you're losing your dollar. Oh, that sucks. But that means that 42% of the time you're winning something.
Not necessarily.
Well, you're winning back your money. You're not losing anything. Let me say it that way. Let me say it that way. You're not losing anything 42% of the time. You might just be winning back your ante, but at least you're not hemorrhaging money. So you can keep playing. The idea is if you get your ante back, you can put the ante back into a game. So remember when I said you walk into Vegas with a load of cash to blow on Chuck-a-Luck? If you roll this, you can keep playing. That's almost like the game didn't even happen, if you think about it that way. And here you're actually positive. Of course, it only happens 0.5% of the time when you 1 in 200.
So don't gamble.
What? Know what's going to happen before you go in. That's one thing students always yell at me, I can't go to Vegas anymore. I'm like, I never told you that. I just promised you it was going to happen if you did. Right? Knowledge is power. Let's do it. What's your average? Negative something. There we go. Uh-huh. You're going to lose about 50 cents, 47 cents per game playing this game, on average over time.
All right, let's
go to Vegas. Now you got to remember, you can never actually lose 47 cents. You're either going to lose $1, you're going to break even, you're going to win $1, or you're going to win $9. Those are the 4 outcomes. That's also, friends, why it's important when you run one-bar stats to make sure you put the L2 in there. Otherwise, you're going to think, holy crap, I'm going to win $2.25 every dollar I bet. Yeah, if you ignore the probabilities, yes. That's why it was so important to make that P of X column. So realize, my friends, that every time you play this game, over time, is better than this. Instead of walking up and handing them $1 and asking them to play, just walk up, hand him 47 cents and walk away. Because that's what's going to happen over time, right? And that'll actually last longer, I guess, technically speaking. You'll be losing dollars at a time in that thing. Does that make sense? Please, Claire.
Okay, is that 47 cents you're losing per
dollar. So in other words, you're giving them $1,
Yeah.
and they're only giving you 53 cents change,
And
I
no
guess.
one plays just one game.
Well, not usually.
You do.
I don't. Actually, I do actually. I went to see Tesla down in what's the one at Lincoln City? There's a casino in Lincoln City. Chinook Winds. Tesla played there, and I walked through the casino. I was like walking through, just kind of smiling. And I saw it. I'm like, I gotta play, dude. Put the $1 in, pulled it, and lost. I'm like, get the ticket. I'm like, yeah, it's awesome. Walk away. But like, nobody just plays one. They play until they satisfy this. Unfortunately, by the time they satisfy this, they've lost all their money. Because this is like negative interest on a bank account, essentially. Please, Joe.
My dad walked into that same casino with $1 and walked out of there with $5 grand for one spin.
Boom! Totally say bastard, don't you say? No, of course! Because the outlier exists. I can walk into the Chuck-a-Luck game, put $5,000 on 6, spin the bird cage, and hit 3 6s, and then I've got how much did I bet? 5,000? I got 50 grand coming back to me. I guess 45 grand technically. It's just not likely to happen. But that's the idea. You never know when it's going to happen. You just know it's going to happen over time on average. That's the danger of it. And also the fun of it. And also Vegas knows this. They know they're making 47 cents on you every time you play the game, which is pretty slick.
Is bingo the same way?
Bingo, I don't know how bingo is betting. I don't know how the betting works. See, I studied this game pretty well, so I know, and I studied craps. I don't know about bingo. Send me an email, I'll look into it, because that'd be another fun way to look at it. I would imagine yes. And the fun thing about bingo is you'd have to figure out all the outcomes of the cards. I was playing I Spy Bingo with Max a couple nights ago, and I noticed that there are some repetitions in the cards, and I'm like, but not everyone. Like, he would hit J, but I didn't have a J. We both hit X. So we have to figure out how many cards there are, and then you get one of those random cards, and then without replacement, the ball's coming out, 2, 25. So that's a more fun question. I don't know the answer to off the top of my head. Please.
So it reminds me of the little old lady who sits there and waits to
Yes.
play.
Yes.
So if you know it's going to pop up 125 out of 216 times, what if she's watching and half of the times have already gone by? Are her chances really better towards the end?
I'm just listening. Very intelligent.
Or
I love the little lady from Pasadena image. I love that. I love that image. Say everything you just said again. I'm going to stop you again. Suppose your little old lady's sitting there, and she knows
that half of the times nobody has won anything, and she's just waiting.
because she knows what?
Because she wants her chances to increase.
I was going to stop you. I was going to stop you in a different place. You started saying something. She knows that on average,
Yeah.
125 times out of 216, but you forgot to put the words on average in there.
Oh.
Remember Joe's uncle who walked into Chinook Winds, pulled the thing one time and it blew. You know what could happen again? That could happen right after Joe's uncle did it too. All this tells us is, if you sit there for an infinite period of time, out of every 216 times it's going to happen 125. But it doesn't tell you when it's going to happen. They could all happen in a row. All 125 of those could happen in one row. It's just not likely to happen, but it could happen. It's just like I could go into the chicken store this weekend to buy 4 little chicks and they could all be roosters. That can happen. It's just not likely. Anybody keep chickens here? Keep chickens? Do you ever have to buy them and get roosters? Did you get roosters if you bought chickens?
No, we got lucky.
You got what? Well, you got probability. Let's make sure we say it right. How many did you buy? How many girls?
4.
You bought us 2, and we got all girls. We're going to analyze those next time, yes? 4, all girls. It's the most likely outcome. Carly?
I was just saying that I had chickens and they told me that they were all hens. I had like 10 of them and 5 were roosters.
That's too high.
Yeah.
As far as 5 and 10, 5 out of 10 is ridiculous. But if you got 10 birds, I would expect one to be a rooster. But really make soup, I guess. But I would expect one to be a rooster. The thing is, you don't know where it's going to happen. They could all come in the same box. 4, the little Happy Meal you buy, they could all be right there. They could all be boys in that little Happy Meal. But the thing is, you don't know when it's going to happen. That's the problem with the little lady from Pasadena approach. That's the problem, is you can sit there and wait, she's due. We have no concept of infinite time. That's the problem with human beings. We have no idea what a long term is. And with technology, look at how impatient we are right now. Why is it never working? We suck at long term. And it's only getting worse as we get older because we're so used to things happening quickly. We have no concept of the geologic time that's being represented with this distribution. Everything is literally a roll of the dice, and you have no idea what's going to happen. That's what's so freaking cool about it, too. Go, Veronica!
Is that how that 100-year average?
That's exactly why I said take it out to, like, say, 100 years. Because you can't look at over the course of a year. It's not long enough. 100 years isn't even long enough, technically, but it's better than 1 year. Which is not as good as 1,000 years. Fair?
Yes.
Yeah.
Well, when you did the Excel thing where it was randomly generating numbers, at first there was a lot more variance, but as time went, the variance was going down and down.
Absolutely.
And down. Is that something you can calculate?
Yes, you can actually calculate the margin of error from the expected probability over a set number of trials. That's just a pure calculus problem, believe it or not. And I wish I could have Excel on right now because I have a simulation of this. And you can actually see those numbers close as the dice keep rolling. It's noisy at first, and it stabilizes over time. So yeah, you can totally calculate. I'm not going to ask you guys to do it usually because it becomes a nitpicky, like an algebra problem. But yes, you can. How long do you have to wait until you're no more than half of a percentage point off of what they should be? And 244, we answered similar questions.
Does it depend on how many columns you have?
Yes, it does. How many different bins, we call them, you have? Yeah, absolutely. We were talking about, for example, Apple had to deal with this with the iPod. They ran into some crap a few years ago with the iPod Shuffle. It's not random enough. People were complaining, too much Dave Matthews, not enough pink. People actually complained about first world problems. My iPod isn't random enough. So Apple had to go in and they checked it like, it is. They're like, no, I'm getting too many Dave Matthews songs. And then Apple tries to explain, randomness clumps sometimes. People are like, no! Like, actually, yes. So Apple had to make their randomizer less random to make people happy. Why? Because we suck at being random. We're humans. You're all sitting in roughly the same chairs you were 7 weeks ago. We suck at being random. You know, it would be great if I came into class and you were on the roof. That would be random. And I'd be confused as all hell. But we suck at being random because of that, yeah? Is that good? Does that make sense?
Well, wouldn't it matter?
What's that? But that's it. I think that's part of being human. It's also why we're still alive over millennia. Is because, you know, randomness also will kill you. And you know, you learn to like not walk in the. I'm gonna randomly walk down the middle of the road today. Good. And then you're out of the gene pool. So I mean, then it becomes, you know. So. Anyway, I have one last distribution I want to play with today. Sorry for that tangent. Well, it.